Hey everyone, welcome to Open Space for Monday, December 14th, 2020. I'm Fraser, Cain, publisher of Universe Today. It feels like sounds like some other show that I do. Anyway, and this is your chance to chat with me live about space and astronomy. Ask me any questions that you've got, and I will try to give you some answers. No interview scheduled so far this week. It's getting a little tricky to find people leading up to Christmas, but I've got a couple of people that I'm going to try to interview. Someone who wrote a book about the history of the Europa Clipper mission, so that might happen. But anyway, stay tuned on that. Also, the virtual star party is going to get a little weird. We're going to be shifting it back a couple of days. So we're not going to be going on this weekend. We're going to be doing it on the 21st, which of course is the Great Conjunction, where Saturn and Jupiter are going to get within 6 arc minutes of each other. It's going to be crazy. You'll be able to see both of them in the same telescope eyepiece. So of course it is going to be our goal to bring that to you live, count down to the moment when they get to their closest point. Corey Schmitz in South Africa is probably going to be on board. We're going to find some people in Europe, and so we can try to get as many telescopes showing at the same time and try to bring you this view live, and you will be there to see the Great Conjunction. All right. Now, as always, live streams here on my YouTube channel are brought to you ad-free, thanks to the support of our patrons. And so this week, I want to give a big thank you to David and Kellyanne, Fridge, Jim Birdsale, James Trainer, Denver Scott, Luciano Bana, and the rest of our 875 patrons. Thank you, everybody, for your generous support. Of course, if you become a patron of Universe Today, you get no ads on Universe Today for life. So even if you stop being a patron, you'll never see ads again on the website, as well as access stuff behind the scenes and videos in advance. So now, this week, I can't think of anything interesting that happened. God, did anything happen last week? Anything Starship related? Anyway, just to give you a reminder, here's the newsletter that I sent out on Friday. And of course, I send out this monster newsletter. Look, I just want to show you this. Look at this. Just keeps going. 1, 2, 3, 4, 5, 6. Keeps going. This is what it looks like. There's no advertisements. It's just raw content, all the cool spaces. And look at all this other stuff. Just goes on and on and on, and cool pictures. So go to universetoday.com/newsletter to get that. But I thought I would just put up the big story, obviously, to remind you. So if anyone wants to talk about Starship, we can totally do that. We can talk about Hayabusa 2. We can talk about Chang'e, Gaia. Astronomer check to see if there's a secret message in the cosmic microwave background radiation. 25 years of solar cycle in one picture. You can literally see, look at this. You can see the moment where the solar activity is high and where the solar activity is low. How Martian explorers are going to be able to extract water and stuff from brine on Mars. It was a crazy week. We've had just some really bonkers space news week after week after week, and we've been running the machine pretty hot over at Universe Today. And in fact, it's sort of because a couple of people are off, we're running low on space writers. So if anyone wants to try their hand at being a space journalist, like seriously, if you're a serious space journalist, just drop me a note, fraserkane@gmail.com, and we could have some openings for a couple of writers. All right, that's the preview. Let's get into the questions, and this one comes from Torrin Atkinson. Hey, Torrin. Question: is there a way to know how much of the moon is composed of ancient Earth rock and how much is composed of Theia rock? Oh man, that is a great question. And unfortunately, I don't know the answer directly, but I saw a paper, feels like it was about a week ago, that proposed a new method for, oh no, that's right. It was on the Weekly Space Hangout. That's right. We talked on the Weekly Space Hangout about ways that how the moon might have formed, and that the rotation rate of Theia as an impactor would have had a big impact, pardon the pun, on the way that the moon formed. So if you got rotation in one way, then you get a moon forming in one way. And if the rotation was different, then you might not get a moon at all. And no, I can't think of a way to know which parts of the moon were made of Theia. I mean, it's literally even which parts of the Earth were made of Theia, because it crashed into the Earth. Now, one of the things that they found, if you watched the what was it called? The miniseries on HBO about the Apollo astronauts from the Earth to the moon. And on one of the last episodes, they talked about how they trained the astronauts to be field geologists, and how they found sort of the perfect rock when they were on the moon, a rock that told the story of the moon's formation and really tied together this idea of the fact that a Mars-sized object crashed into the Earth. But I don't know. That's such a great question. I will, I review these afterwards, and so when I see this part, I will, I'll try to see if I can find an expert and do an interview with them about it, because it's such a great question. Thanks, Torrin. All right. Let's go on to the next question. So Pacer asks, where did all of our water come from? There are differing opinions on it. Yeah, the question of where the Earth's water comes from is actually still an open question in science, but it's getting less and less open. They're starting to get a pretty good resolution to the answer now. So originally, okay, so I'll tell you what the problem is. The problem is that the Earth is too close to the sun. So, there's this thing called the frost line in the solar system. And essentially anything that's closer than about halfway in the asteroid belt, no water can exist on the surface. It just gets blasted away by the radiation of the sun. It just sublimates off into space. Once you go outside of this frost line, on the far side of the asteroid belt, out to Jupiter, then water ice can remain just ice on the surface. And so that's why you can have an icy moon around Jupiter, say Europa and so on, but you can't have an icy moon around Mars or Earth. And yet we have this weird mystery, which is like, why does the Earth have water? Why did Mars have water in the past? And so the question is, if the radiation from the sun was blasting away all of this water all the time, then it shouldn't be here. And yet it is. So So there's been a couple of theories to figure this out. One idea is that the Earth formed dry as a bone, and then comets crashed into the planet and delivered water, one after the other. And then since the Earth had that magnetosphere built up, then it would protect any of the water that was accumulating onto the planet Earth. The other idea is maybe asteroids did it, that there's water locked into asteroids. And so when the asteroids smash into the Earth, like that conversation about Theia we talked about earlier, that it would build up more and more water inside the planet. And then the other idea is that it just was there, and it just formed as part of the formation process of the solar system. And it's starting to really lean more in that direction, that there was enough water-rich just material that was still kind of covered by the radiation from the sun. And as the Earth formed, this water material just kind of collected together. Some of it still locked inside the Earth. Some of it made its way up to the surface, but it was always protected by the magnetosphere. So it's still an open question, but I think the tone of the papers, the tone of the stories that I'm seeing these days are that it formed in place, that the Earth scooped up the water out of the solar nebula as it was growing and formed. All right, lots of great questions now. Wow. Teox Trader asks, could AI alien life be friendly? That's a great question. So let's try to figure this out. So let's assume that you've got some advanced civilization, and in the far, far future, like, us, right? We will be able to build some kind of self-replicating robots that we will then use to explore the Milky Way. And let's say that they find various locations, and we discover that there's life over here and there's this kind of a planet over there and whatever. We're just doing exploration. And then we take this knowledge that we discover and we freak out. we reach out and try to have some kind of friendly communications with them. Who knows what we would do. But there's sort of a thinking that would go, if we were able to reach out and go from world to world, then we would expect that other civilizations would be able to reach out and go from world to world, and they would theoretically be a threat to us. And we're relatively peaceful, Star Trek, etc. But if we were an artificial intelligence and our goal as an artificial intelligence was to acquire more resources to make more computronium, then you can imagine an artificial intelligence seeing other civilizations as, at the most, a potential threat, and at the very least, something that's already using the resources that you want to use. You as the artificial intelligence want to use that power. You want to use all of that material for computronium. So, of course, the answer is that we can't really know what the behavior, what the psychology of an alien artificial intelligence civilization is going to be. But I think we can expect it to be vastly different than us. And even like our artificial intelligence is going to be the most alien things that we can exist with. There's no reason to believe they're going to have the same kinds of goals that we do. So I think artificial intelligence civilizations will be a pretty big threat to us in the future. All right. Okay, so Julius Stenionis asks, if there was another planet like Earth with all its parameters, radio signals, etc., how far could it be so that we could detect life on it and be able to detect technology on it? So we sort of imagine in the past that Earth has been sending out these radio signals into space. We've got like the opening announcement of the Olympic Games, and we've got early radio broadcasts and things like that. And then over time, more, television, reality shows, all kinds of stuff. It's all just being broadcast out into the cosmos. But the reality is that the amount of, as radio waves expand out into space, they follow the inverse cube law, and fall off very rapidly. And so it's actually really difficult to detect a signal that's going out from space. And so when we think about our ways to detect alien civilizations, the vast majority of attempt so far has been a directed SETI approach. So essentially, you're looking at star after star, trying to detect one of these civilizations, sending a beam directly at the Earth, as opposed to just the leaked radiation. But the thing that's kind of interesting is, like, there's an upcoming telescope called Square Kilometre Array that's being built in South Africa and in Australia. And once it's completed, it will have the ability to detect the leaked electromagnetic radiation, say the radio traffic of all of the Earth's airports, to a distance of about 100 light years, which there are a lot of stars within 100 light years of the Earth, a few thousand. So we will have the ability, just with the Square Kilometre Array, just in about 10 years from now, to detect the leaked radio transmission from an alien civilization that is flying a lot of airplanes. But the other way, of course, to be able to do it is for us to do direct imaging. And essentially, you're going to be looking at the atmosphere of an extrasolar planet, and you're going to be trying to detect some kind of substance, some kind of chemical in the atmosphere of that planet that will tell you that there is life there, and even potentially if there's civilization there. If you detect something like chlorofluorocarbons, or which is the thing that's used, that's causing the ozone layer depletion, or other products of like factories and things like that, then you could be pretty certain that there are civilizations there. Now, the next big round of telescopes that are coming online, the Extremely Large Telescope, James Webb, and even sort of the next generations that are going to come after that, LUVOIR, HABEX, things like that, they're going to be able to detect biosignatures. So they're going to theoretically be able to directly image Earth-sized worlds orbiting sun-like stars and detect life, the processes of life that are going on that world. being able to detect industrial processes will be a next step. So I think we'll need some kind of future telescope to be able to do that kind of capability. But I would say that we are within orders of magnitude to be able to directly image other worlds and detect if there's civilizations there. There's a lot of really great ideas, like looking for their light pollution at night on the planet compared to the way it is during the day, or looking for, like, there's been some great ideas for how you could detect a technological civilization, and they're called technosignatures. And so I would say that we are within a couple of decades of having a suite of tools that will let us detect technological civilizations orbiting around other stars in our vicinity. All right. Havy Scott and Flower. Why isn't metallic hydrogen fuel for rockets being created by the compressive implosion of an outer spherical shell, like in the core of nuclear weapons? So I don't know, but I'm going to try and sort of at least give some background on this. So metallic hydrogen is a form of hydrogen that's found at the core of Jupiter. And it is this place that is under enormous temperature and pressure. I think it's like 90,000 degrees Celsius at the core of Jupiter. And so hydrogen, just what would be a nice gas here on Earth, is compressed into a metal. And in that process actually is what generates the enormous magnetosphere that surrounds Jupiter. And it's widely believed that if you could get your hands on this metallic hydrogen, then you would have a fuel source that is incredibly dense, denser than regular liquid hydrogen, denser than solid hydrogen. It is next level. You could start to power some of the starships that we see in like the Expanse. You could have a spaceship just take off from Earth, fly to orbit, and fly around with metallic hydrogen. So it would be great. And it looks like metallic hydrogen has been made in the lab, maybe, and only under the most extreme conditions, essentially creating an enormous vise where you squeeze, like a vise as hard as a diamond with enormous pressure, squeezing together just a tiny amount of hydrogen together and getting it to turn into its metal form. So, could you use a nuclear bomb to explode it? Maybe, briefly, but I don't think that metallic hydrogen is stable I think it wants to turn back into solid or gas or liquid depending on the temperature. So, can you grab that, Logan? Someone's at the door. Probably a package. It's Christmas time. All right, sorry about that. So it's probably going to expand as soon as it gets, as soon as you take the pressure away from it. So I think a lot of the big challenge is going to be being able to handle you're going to create the metallic hydrogen, and then you're going to have to keep it under pressure. It's sort of like a different challenge of creating antimatter. You're going to have matter and antimatter, and you're going to have to keep that stuff apart. You can't let it touch. It's incredibly dense energy form, but you can't let it touch. And so really, I think both are going to serve like batteries. You're going to take an enormous amount of energy, compress metallic hydrogen down, and then store it in some way that you can keep it compressed, and then you can use it in a very dense form when you need it. Same thing, with antimatter, you're going to use an enormous amount of energy, create antimatter, and then you're going to have some really complicated metallic or magnetic field that's holding it away from anything else so that it doesn't annihilate. So both are going to have their challenges. So it's just like we kind of know this thing exists, but it's way beyond our capability. John F. Is there water or oxygen on Titan? It seems like low-tech combustion engines and their waste heat would be a great fit. Yeah, there is plenty of water on Titan. So the cool thing about Titan, right, is that you've got on the surface, we know that it has liquid methane, it rains methane, and various other hydrocarbons are across the surface of Titan. So we know that it's very rich in what would essentially be rocket fuel here on Earth. And so at the same time, that's all layered on top of ice. It's layered on top of, like, pretty much the whole outer layer of Titan is kind of like Europa, just covered in ice. Ice mountains, ice sand, ice boulders, and it goes on for kilometers. And then underneath that, there is probably a liquid water ocean. And then underneath that, there's probably a solid rocky core. And so the cool thing about Titan is that it's sort of got the whole package. It's both got the hydrocarbons and like the building blocks of life at the surface, but then it's also got this liquid ocean that's underneath. And so the real hope is that maybe there's some kind of process that's moving chemicals from the surface of Titan into the interior, mixing with this under ice layer of, the subsurface ocean, and then somehow stuff is getting up and back to the surface. And so it has the thing that Europa lacks, which is this incredible methane hydrocarbon rich environment. And so, yeah, if you could land on Titan, you could mine the ice, use energy to mine the ice, turn it into hydrogen, oxygen, then you could use the oxygen to work with the methane. But it's very cold on Titan, and so it might just make the most sense to just use electrolysis to break up the water into hydrogen and oxygen, and then use that as a rocket fuel. Hydrogen and oxygen make a great rocket fuel. So I'm not sure what is going to be more efficient, but there's definitely lots of oxidizer. It's all locked up in water, and lots of fuel in the form of methane. All right. So 6 Bob Ohms is saying, I thought metallic hydrogen was stable after created. I don't know the answer to that question, so I will look at that one. Okay. So I see the ATL 530 question. What are your thoughts on the theory that instead of strings, the fundamental building block of the universe is a piece of energy? I saw that article on The Conversation, and I haven't really dug into it. That's the kind of thing that I would bring in a ringer. I would have Brian Koberline or Paul Sutter on Universe Today cover that story, because it's beyond my pay grade. All right. So Raphael Domenichini, all planets and moons in the outer solar system are rich in water. Yeah, when you think about the planets, I mean, okay, so Io, so Jupiter's moons, Io is not, but Europa, Ganymede, and Callisto are rich in water. And then when you look at Saturn's moons, Enceladus, Rhea, Dione, Titan, they're all rich. And then you think about the ones for Uranus, Neptune, they're probably very water rich. Pluto is incredibly water rich. So the assumption is that essentially the entire outer solar system is water, which is sort of interesting. I did a collaboration with Isaac Arthur a couple of years ago, and we talked about this idea that what the inner solar system has is metal and rock, and what the outer solar system has is water. Actually, the inner solar system has energy too, with solar power. And so there will be this economy in the far, far future where the outer worlders are delivering water to the inner solar system, and the inner and other volatiles, and the inner worlders are sending rock and metal and energy outward. And you can imagine there's going to be trade between the inner and the outer, and the belters. Man, Expanse starts in like 2 days. Is anybody else as excited as I am? Guardian 1032. Do stars leak hydrogen? I play Elite, and one game mechanic is fuel scooping stars. I realize it would probably be easier to scoop gas giants, but is this a thing? Do stars leak hydrogen? Yeah, stars do leak hydrogen in the form of their solar wind and various coronal mass ejections. So right now there is this non-stop wind of protons and other atoms blowing off of the sun out into space. It's the thing that will buffets against the Earth's magnetosphere, and is the thing that even the Voyager spacecraft are detecting way far out beyond the orbit of Pluto. And then you also get the coronal mass ejections, these huge blobs of plasma they're sort of lifted up by the magnetic fields on the sun and thrown out into space, and then they can reach Earth in a couple of days, and that's what causes the auroras. And there's all kinds of particles that are happening, but there are a lot of them are protons, are essentially just hydrogen. And so you can imagine theoretically being able to just sit around and collect these protons of hydrogen. Or you can imagine that you are attempting to actually speed up the process. And so it's this idea called stellar lifting. And so if you can set up like a magnetic field that is churning around the sun, you can force the sun to kick off more hydrogen than it normally does. And so you could direct it. And so then you could probably scoop it away. You wouldn't want to like take your spacecraft and dive into the star and scoop it up and fly away. The gravity in the sun is kind of intense, and of course the temperature. I mean, you're looking at 5,800 degrees Celsius on the surface. No, 5,500 Celsius on the surface. Like, there's no metal. There's nothing can handle that kind of a temperature. And so you get close and you just will have a vaporized spaceship. So, and I can't even imagine some future mega alloy that can handle that kind of a temperature. So, stick to the gas giants. So Visto Tutti says, your discussion on building solar farms on the moon was fascinating, but what of the lunar agreement? Can a nation build and own the facility? We're in a really weird time of what are the rules of space exploration right now. The Outer Space Treaty was super vague about what people are allowed to do. They said, you're not allowed to own property on the moon. So anyone who's selling you acreage on the moon, it's not real. You're not allowed to prevent, you can't call the moon, in the name of Canada. Or set up as a protectorate or a territory or whatever. If you set up like it's for the shared use of all, you have to set up a research. If you want to set up a research station, you have to allow anyone to come and use your research station as well. No weapons in space, no nuclear powered super soldiers on the moon. But how much are you allowed to use to maintain the ongoing capability of your research station? Are you allowed to mine the lunar regolith to get water and fuel and such for your station? Probably. So most recently, NASA and 8 other countries have signed this thing called the Artemis Accords, and that sort of is starting to flesh out what the rules are for going back to places like the moon and asteroids. What are the rules for how you're able to extract resources? Who can get it? What kind of rights? What laws is it covered under? Things like that. So right now you've got, like I said, 9 countries have signed it. 2 big ones haven't. So, Russia and China, which isn't surprising. So if China goes to the moon and sets up a big mining facility, that wouldn't break the Outer Space Agreement, because they're not building nuclear weapons on the moon. They're not, there's no super soldiers on the moon. So that would be fine. But it would be bad, I think. We can all agree. So I think we're going to see, as it's always been fantasy land, right? No one's ever thought this would ever be possible. And now suddenly we're entering a time where these kinds of things will be possible. But I don't think we really have to worry about it in the near future, because the reality is there's no good reason to harvest any resources from the moon at all, ever, and not helium-3, right? Helium-3 is like, there's a conversation on Twitter, we were talking about this today. Helium-3 is like magic. It's a kind of nuclear fusion that might work better, but no one has made a fusion reactor work. And no one's made a helium-3 fusion reactor work. And no one's been able to miniaturize a helium-3 reactor for use on a spacecraft. And even if you wanted helium-3, there's plenty here on Earth. And it's right here. Like, you just got to get it. So, I mean, there's no, like, and someone was saying on Twitter, yeah, if you want like, just bucketfuls of shattered glassy rock, then the moon is your place. But the key is that if you go to the moon and you need, say, water or, say, glassy rock to build a house out of, it's right there. And so I think that for the near future, like for the next 50 years, at least 50 to 100 years, we're going to see the bare minimum resources acquired on the moon and the asteroids to support the exploration of those places. Like our impact, our footprint on the moon is going to be negligible. Same thing with Mars, same thing with the asteroids, etc. And then at some point in the far future, the next 100 years, 200 years, we will gain more just capability and technology where we're starting to live more and more in space. And then suddenly the exponential curve will take off again. And suddenly we will have dismantled the entire solar system and turned it into a Dyson swarm. So at some point in the next 100 years or so, someone should sort this out. Tom Watson, is there any chance the known universe is orbiting the mother of all black holes deep in the universe, in the unknown universe? So you're asking, is there like just a monster black hole that a huge chunk of the universe is orbiting? Well, like let's imagine that. Well, okay, hold on. Let me just sort of set some up here. So your understanding of the universe as a great big sphere is wrong, right? The universe, and we've talked about this quite a bit, but the universe is not a sphere. The universe is a grid, three-dimensional grid that potentially goes on forever. It appears to a sphere for us because as we look out into space, we're looking backwards into time. And the limit that we can see in all directions is the beginning of time. And so it's not really a sphere. But if there was some immense gravitational object that was sucking things towards it or things were rotating around it, we would be able to detect that. I mean, the whole idea of the great attractor is for the longest time, people could see that all these galaxies were sliding down on the other side of the Milky Way, but they couldn't see what it was going towards. And so now with modern telescopes, radio observatories, and infrared observatories, we're able to see through the dust and gas of the Milky Way and see the galaxies that cause this cluster. And so there are some monster black holes in there. And astronomers have seen even bigger, multi-billion solar mass black holes out there across the universe. But if there was something bigger than that, we would be able to sense it. We would be able to see this just common motion that is moving around some hidden mass. And we just don't see that. We see, at the largest cosmic scales, we see walls of galaxy clusters all pulling in together, voids opening up in between them. But it sort of looks the same no matter where you go. It's kind of amazing. All right, some people wanted to know what are the things behind me. I'll just show you here. Got these are Parsec Awards. So we won 3 years in a row for the Guide to Space. Parsec Awards. Oh, baby. Oh, this is a meteorite. It's about a pound, but it's getting really cracked and flaky. I gotta oil it, or else it's just rusting. So, but it's so cool. It's like a pound of space metal. So it's like one of my favorite things. Yeah, I gotta fix this or it's just gonna disintegrate. Yeah, and then I've got more stuff along the wall. So, oh man, maintenance is not my strong suit. Anyone who's worked with me knows. All right, let's move on. Zach Perry, are we still looking at the 2030s before we see an orbiter around one of the ice giants? Why hasn't there been more appetite to explore them? Yeah, there's no concrete plan to send any spacecraft to any of the ice giants. The most concrete one is the Trident mission, which is probably going to be a Discovery class mission that's going to go to Neptune's moon Triton, but you're still definitely not looking before the 2030s. Like it takes 10 years to get out there. If you're going to try and this is just going to be a flyby, like not even an orbiter. It's rough. So, no, like just be patient. But there's a lot of good stuff. Like people always have their mind set on one thing. They're like, all I want is the Dyson swarm. All I want is to terraform Mars, and I'm not interested in any of the steps in between. And the reality is that there's lots of cool stuff. We're going to see the Vera Rubin Observatory come online like next year. That's going to be a mind bender. We're going to see the next data release coming from Gaia. We're going to see a new target for Hayabusa 2. We're going to see a sample return from OSIRIS-REx. We're going to see Artemis landing human beings on the moon. We're going to see Starship fly. We're going to see the Dragonfly helicopter going to Titan. We're going to see Perseverance is on its way, and it's got a helicopter on board as well. So there's the extremely large telescope, which is coming online in 2026, 39-meter telescope, capable of directly imaging Earth-sized worlds orbiting around sun-like stars. James Webb, October 31st, 2021. For real. Nancy Grace Roman telescope. There's so much good stuff. So I know you got to wait for the 2030s, but you just focus on all this other good stuff that's happening. You won't even feel the time. You just be like, oh, what do you know? It's time for the Triton mission to send back, or the Trident mission to send back its pictures of Triton. I can't wait. Rich Wilson asks, how long before the alien parasite living in that meteorite finally escapes? Yeah, it's working its way out. From ATL 530, what is your favorite lunar lander at the moment, and which is most likely? So I don't have a favorite lunar lander right now. I mean, Starship as a lunar lander is kind of a cool idea, although it's needs a big ladder. And the Blue Origin one looks like a very standard lunar lander. But the thing that I really like, that I'm really excited about with the upcoming Artemis mission, is this idea of every step of the Artemis program being reusable. So you've got the rocket takes off from Earth on, say, like maybe a New Glenn or even a Starship, flies to the Lunar Gateway, and sends the descent module and a new piece of hardware called the transfer module, and then as well as the ascent module. And so then the capsule arrives at the Deep Space Gateway, and then of course it can return back when it needs to. But then the transfer module carries the descent and ascent vehicle to low lunar orbit, and then returns back to the Deep Space Gateway, and then it can be used again. So it's like a ferry that takes you from the Lunar Gateway down to a lunar insertion orbit and back again. And then the lander lands on the surface of the moon. The astronauts jump out, do their thing, and then the ascent module comes back up to the Lunar Gateway. So the only part that's left is the descent module. But if it lands at the future lunar base where they're starting to build fuel locally, then they can refuel the descent, or the descent module, and have it fly back up to the Lunar Gateway. So we can get to this point where there's a ferry boat that's going from Earth to the Lunar Gateway, and from the Lunar Gateway down to the surface of the moon and back. And there's a base on the moon, there's the Lunar Gateway, and then there's Earth and the International Space Station. You've got these flights that are going in between all of these places. And eventually, you then extend that idea. You've got flights that are going to, say, Phobos, and then there's a base on Phobos, and then flights from Phobos down to the surface of Mars, and then back up. And so I think that's the way we stay. That's the way we go off Earth and don't just plant a flag and return. And you'll know that we're going in the wrong direction when the focus is on just having people stand on the moon again, because we did that. That happened. It's time to go and stay. I want us to have this point where we look up into the sky and we know that there are astronauts on board the International Space Station right now. We look up at the moon and we know that there are astronauts on the surface of the moon right now and have been there for 20 years. And then we look at Mars and we know there's people on Mars right now. That's when we feel like we're really starting to become a true solar system faring civilization. So my favorite lunar lander is the transfer module of the Artemis system. Bet you didn't see that coming. Mr. Man, why do you think the general media is poking fun at the SN8 explosion while overlooking the tremendous success of the flight in general? I made fun of the SN flight in general. I believe the joke I made on Twitter was, breaking news, Starship. That was all I said. But I think, why are they dismissive? And I think that is because they either are just going for clickbait, or they just don't understand the incredible accomplishment that was made last week with Starship, with prototype number 8. When you look at what happened, up until this point, you had the water tower flew, and then the grain tower flew, and then on Wednesday last week, you saw the full prototype with the wings, with 3 Raptor engines on board, with the main fuel tanks, with the landing tank installed, the header tank, all ready to go, with the software, the computer technology to make this thing do its flight and test out a whole bunch of things. And so then it took off after like 1 day's delay, which is like nothing, flew to its altitude. That's incredible. Using 3 Raptor engines, which it turned off as it needed. Then it did the belly flop maneuver, and then was able to keep itself perfectly aligned as it was free falling back towards the Boca Chica landing site. Then at the right moment, it kicked out the bottom, got itself into a landing position, restarted the engines, using the header tank to be able to deliver fuel when the main fuel was all sloshing around, and slowed its descent and then crashed. So it was almost perfect, and the one part that failed was no big deal. Like if there's one thing SpaceX knows how to do, it's how to make rockets land where they're supposed to. It was all that other stuff which was the challenge, especially 3 Raptor engines firing in unison. That's never been done before. And although you could see that beautiful green color as the thing was landing, as it was consuming its own rocket engine, that might need to be looked at. But apart from that, it was flawless. It was incredible. Yeah, there was an explosion in the end. That's too bad, but it was in the large scheme of things, it was no big deal. And then of course SN9 tipped over in its bay. So clearly, a few more kinks need to be worked out. But still, and I've mentioned time and time again the hop. I anticipated the hop to be successful. It's the orbital return, which is just gonna be that line. There will be like a before orbital return and an after orbital return in human society. There will be the day a Starship returned from space and landed safely. And that's the day when everything changes. That just from that point forward, our destiny in space will be different. So, maybe that'll happen next year. So we'll see what happens. Apologies to everyone listening. So Raphael Dominichini, can ion engines be scaled up to work on crewed spacecraft? Even if we have functional nuclear reactors on the ships, would it be worth it? So an ion engine is the perfect method of propulsion in space, where you don't have to fight against the gravity of the Earth. Like, you cannot use an ion engine to take off from Earth, but you can use an ion engine to accelerate yourself in space. And it's pretty much the most efficient way, because you're using, say, a form of energy, electricity, solar energy, and then you're using that to accelerate your spacecraft. And then you're just throwing out ions at incredible velocity. You're throwing them out at like, I forget the speed, like hundreds of thousands of meters a second. It's really fast. And so that gives you an enormous kick. You're turning electricity into velocity. But the problem is, you still can't really do more than like the force of a piece of paper. But you fire it for a long, long time and the energy builds up. But there have been these ideas for higher thrust ion engines. Still not high enough to like take off from the Earth, but higher, they could accelerate more mass. And you would need some kind of nuclear reactor on board. And so you can imagine some future spacecraft that has a nuclear reactor on board, and it's using that to generate electricity, which is using that to fire these really high power ion engines. Yeah, in theory, it's a great idea. It should work really well. The challenges are, of course, running a nuclear reactor on board your spaceship where you have human beings nearby. That's going to be a challenge because but I mean, people have worked out in theory how this would work. So maybe you separate the crew, maybe there's, some kind of space between the nuclear reactor and the people. Anyway, it can be figured out. So we'll see. I think the one idea that we never saw was there was going to be a mission to Jupiter that would go to all of the moons of Jupiter. It would sort of fly to one Jupiter moon, go into orbit for a while, and then leave that moon and then move to another one and go in orbit for that one for a while. And it used one of these nuclear reactors with high performance ion engines, but it ended up getting canceled. So the Jupiter Icy Moons mission, JIMO. So, but I think it's I know in like The Martian, I think they use this idea of an ion engine, nuclear powered ion engine tug that went between the Earth and Mars. And that's a pretty effective way to be able to do that, to give you that change in velocity that you need over long periods of time. But I think when humans are involved, you really want to just shorten the flight time as best you can. And an ion engine, although it gets you going really quickly over long periods of time, it doesn't really get you going quickly in the short term. And so I would probably anticipate instead it's just going to be just a gigantic chemical rocket that you're going to see. That's what Starship is going to be. Starship is going to launch, it's going to refuel, and then it's going to have a really big pile of propellant on board, and it's just going to, fire the rockets and make the transfer to Mars in the shortest possible amount of time. Hello to Launchpad Astronomy in the chat. If you haven't checked out Launchpad Astronomy's channel, you definitely should. He's got some great videos. All right. Douglas Smith, since the Falcon 9 fairing is 5 meters wide, could it carry the Orion spacecraft, which is also 5 meters wide, to orbit or to the moon? I forget the exact weight of the Orion capsule, but it's very heavy. It's too heavy for a Falcon 9. But a Falcon Heavy could probably pull it off. Probably not in the same kinds of flight profiles that the Space Launch System could do, but the Falcon Heavy has been pitched as a replacement. Same thing as the New Glenn. So both New Glenn and the Falcon Heavy could essentially be fill-in replacements for the Space Launch System for most of the missions that are being looked to be done. So you could launch the Europa Clipper on a Falcon Heavy, but you would need a couple of flybys of like Earth and Venus to build up the velocity to get out to Jupiter. You could build the Deep Space Gateway and even send crew to and from the Earth to the Moon using a combination of Falcon Heavies, Crew Dragons, and things like that. So the only reason that hasn't been done yet is politics. And you can see under the current administration with Jim Bridenstine, he was attempting to shift the path from the Space Launch System to an alternative, less expensive combination of commercial and NASA hardware. And so I wouldn't be surprised. I mean, and we talked about this last week, people don't realize, but in fact, the Crew Dragon is bigger inside than the Apollo capsules. There's more room inside. And an upgraded Crew Dragon could make the trip to the moon. And so we talked about that idea of the capsule is going to take you from the Earth to the moon. You could fly a Crew Dragon and do that because it only takes a couple of days to get up there. And so you just need a few more supplies. So I would not be surprised if when Artemis finally does happen, the astronauts are launching on a modified Crew Dragon on board a Falcon. No, they won't be launching on board a Falcon Heavy. They'll be launching on board, because it's too dangerous. They'll probably launch on a Falcon 9 expendable to the Deep Space Gateway, and then all of the other parts of the mission will be sent on New Glens and Falcon Heavies. I think we can see that go. So I really don't think that Space Launch System is going to launch more than a couple of times. It's at this point, compared to the other launch systems out there, it's just kind of no comparison. It's too bad. It's the most powerful rocket that's ever been imagined. More powerful than, well, not more powerful than the Starship. Starship just takes it all to the next level. So, especially with orbital refueling and full reusability. Come on, this is crazy town. All right. Horizon Brave. Fraser, no politics, but are you sad to see Mr. Bridenstine Stein step down? I'm ambivalent. I think that he was surprisingly good for NASA as an administrator under the current people who were chosen for various positions within the government. Did his best to try to get NASA away from all of the entrenched political interests that were happening. But is he the best person for NASA? I don't think so. I mean, I can imagine tons of people who would be amazing to run NASA. So if you could look at the entire pool of the most qualified candidates across the entire American civil service, I'm sure you can find some amazing candidates. So I think that he was good, which is, I know, it's like, wow, he did a great job. Good job. Zach Perry. They're creating a horizontal launch spaceport right near me that advertises itself to be of national significance. What are the capabilities and limitations of horizontal launches? That's a great question. So when you think about the vertical launch, let's imagine sort of the perfect version of the vertical launch. We'll imagine the Starship. You've got with the Super Heavy booster. It can take off. The Super Heavy returns to the launch site for rapid reuse. The Starship flies to orbit, can refuel in orbit, returns to the landing site for rapid reuse. Everything's great. If you were to build some kind of horizontal takeoff facility, you would need to build a vehicle that launches off of your runway using jet engines, which is effective. Is cheaper than using a rocket to get you up through the majority of the atmosphere. And then you'd have to switch to some kind of rocket system. And then you would probably need to have a 2-stage vehicle. So the first stage would then return back to the launch site, ready for rapid reuse. And then the upper stage would fly off into orbit, and then it would return aerodynamically back to the landing site. And so you would get some savings for your launcher, because you wouldn't need to have as much fuel because you'd be using your oxidizer from the atmosphere, but your whole vehicle would have to be aerodynamic, and that is an expense. It's just the most efficient to just have a big tube filled with fuel and have it just take off. It's simple, it works, and if SpaceX can realize rapid reuse, then it's game over for every other idea in town. Maybe there'll be some need for small payloads launched by these air-breathing rocket systems. I mean, the one that everyone's thinking about is the Sabre system, but even that, I think, it just doesn't compare. And a single stage to orbit spacecraft is right out. There's no, like, literally the laws of physics. There's no way you can make that economical compared to a 2-stage fully reusable rocket. And that's the Skylon, which people are talking about. So someone was talking about the Dragon. Where'd it go? Sea Dragon, yeah. So someone's asking about the Sea Dragon, and people always want the Sea Dragon. There, Larry Beckham was asking about the Sea Dragon, and the Sea Dragon is now. I mean, it was a great idea. Like, if you want to build a big, like, the most efficient rocket to build is the biggest rocket that you can build. The biggest rocket that you can build is too heavy to launch from land, so you launch it from the ocean. It's a clever idea, but there's downsides, like getting the thing out into the ocean and having it take off from within the ocean. But once we get to 2-stage reusable rockets, like the Sea Dragon was not reusable. Sea Dragon was just about getting an enormous amount of payload into space, but it would burn up just like all previous rockets after that. That once these starships are flying and they're getting reused and they're being refueled, then nothing competes to that. The only successful competition is going to be bigger versions of Starship. So there will be someone will work out the math, and eventually there will be the final giant Starship that will be a 2-stage monster rocket. It'll be, I don't know, 18 meters across. It'll be some size that is literally the limit of what materials on Earth can handle. And that will be the most efficient way to carry cargo into space. So I wonder if anybody's ever done that. Has anybody done the math on what is literally just the most powerful 2-stage rocket that can be built? But the thing that's kind of interesting, and I've sort of was talking about this a bit last year, that the need for rockets is going to be short-lived. That we're in this intermediate phase where we're going to need rockets to build our infrastructure in space. But once we're there, once we've got orbital factories that are building rocket systems, then your need for actually launching material off planet Earth goes away. The only kind of rocket that you're going to need is going to be to carry people and a few really important, really difficult to build electronics and things like that. Everything else, food will be grown in space, water will be harvested in space, rock, regolith, metals, it'll all be manufactured in space. You'll be printing solar panels on the moon. You'll be doing every part of this out in space. And so the need to carry rockets for giant rockets are going to be carrying people from Earth to space will go away. It'll no longer be required. So I wouldn't get too caught up on what is the biggest possible rocket that we could build. After a while, it'll be more about how can we shuttle material from place to place in the solar system. And then there's no limit, right? Space is like the ocean. And so think about what super tankers look like. That's what space will look like. You'll have spacecraft that are, and even without any of the physics of super, like there's no water, there's no friction. So you're going to have, it all just comes down to delta V. How much change of velocity can you impart to your cargo? So you're going to have an asteroid be completely dismantled and stripped into metal, and then a giant space tanker is going to carry that to its destination. It's going to be, our imaginations are not prepared to really truly comprehend what a fully operational solar system spanning civilization is going to look like. Romulus XC. Why does it take years for even robot landers to go to the moons of Jupiter? Because Jupiter is really far. If you just like really hightailed it with the most powerful rocket with the smallest possible payload, it's still going to take you many years to get out to Jupiter because Jupiter is just far. It's 1 billion kilometers away, while Mars is only like 250 million kilometers away. So it's like 4 times farther away than Mars. And so it just takes a long time. And it's also really important to understand that as you're getting away from the sun, it's not like like when we imagine the solar system, we imagine the sun in the middle and all the planets going around it, and you imagine these orbits going around, and you go like, it's like you're jumping from one track to the next track over, but it's not, right? It's a mountain that you have to climb. So think about instead, if you're on the ground and you've got this big mountain beside you, and that's where Jupiter is at the top of that mountain. You have to climb that mountain, and it sucks, and it takes a lot of energy. And so in order to be able to climb that mountain, you need to be able to send a spacecraft that is a lot of rocket with not a lot of payload to be able to make that distance. And so it's very either, you can either send very small payloads, but if you want to send a big, beefy robot, then you need to have a big booster, or you have to do these very complicated maneuvers to get gravitational slingshots to get you out to that distance. So it's just far and it's hard to get to. All right, we've reached the end of this week's Open Space. Thank you, everybody, for asking all of the questions. I really appreciate it. Thank you to all of the moderators, and especially thank you to Nancy Graziano for copy-pasting all of the questions in a way that makes it really easy for me to be able to read them. Of course, if I didn't get to all of your questions, go ahead and just put them in the comments. If you haven't already, you should subscribe to my weekly email newsletter. I talked about it at the beginning of the show. universetoday.com/newsletter. It's a magazine, free, no ads. I write it by hand, comes out every week, and it'll keep you busy on all of the space news that I'm aware of. And if you read that, then you'll start to sort of see where I find all my sources and how I find all this content. So again, super fun. Thank you, everybody. And I have no interview planned so far this week, but I want to. So stay tuned. All right. We'll see y'all later.